Hello. All right, we are live now. Let me check the stream. We are live, but we start in about 5 minutes. Just wait for a few people uh, get in here. All right. Yeah, we do have a few people on the stream. If you have any question, just put the question on the chat. On the replay, the video chat will not show. Just on the live stream only. Let me change a few things. Right, that is better. Uh, is that on lab 1 or lab 2? Right. Yeah. So I said I will, if I see a problem or a question on the chat, I will do that first. Otherwise, I will go back and forth between the question. So the question can be either from lab 1, lab 2, or in the homework. Right. I have a question on lab 2, number 3. Let me type that. Right. Lab 2, number 3. So the first thing when we try to find the limit, I will put in the number. Put in 3, so we have 3. And that is undefined. and if it is undefined, then the limit does not exist. Right. So that is that. Since we're on this one, just want to go to 2 and 4 quickly. Right. 2 and then 4. Right. Because we're on this page. Anyway, the first thing, as always, is to find the limit, put in the number. So put 2 in for x, and I have 0 over 0. 0 over 0 is indeterminate. When that happens, we cannot say whatever the limit is. We have to try something else, and that something else just happened to be for this problem, because we have 0 top and bottom. When we put in 2 for x, which means x minus 2 must be a common factor. Because if it is 0 when x equal to 2, then x minus whatever the number is, in this case 2, it's going to be a factor. And then the remaining factor we just need to determine. We're going to need x squared, so we need an x, and we need minus 4, so it's going to be a plus 2, because plus 2 times minus 2 is going to be minus 4, right? So when we have 0 over 0, we should factor, and they should have a common factor of x minus the limit. So say that. And then so we can put 2 in for x, and that is 4, so that will be the limit. So when we have 0 over 0, x minus 2 is a common factor, right? So that was 2. Yeah, I go to 4 first, and then I go to 5. Right. Right, now 4. Right, I'll do the same thing. Put 4 in for x. Have over 0, and this of course also indeterminate. So it's not going to be like that. The limit have to be found differently. So I start with the problem. Right. The difference between this one and on 2 is that on 2 we can factor. On this one we cannot factor like what we did earlier. I have to try something else. What we do instead is we're going to multiply by the conjugate. And the conjugate is not the conjugate is whatever that has the square root. So this one we have square root of x minus 2, so we have to consider the conjugate of that. X minus 4 at the bottom, we don't need to do anything there, just need to do the conjugate where there is the square root. That is the conjugate. So we'll multiply it out. Square of x times square root of x is square root of x squared. Square of x times 2 negative square of 2 times square root of x, and minus 2 times 2 minus 4. We will not multiply the denominator, just leave it like that. Right. On the top there are a lot of things to cancel. The middle terms, the square with the square root, and we just have x minus 4 on the top. Right. Now just want to do the comparison between 2 and 4 here. Both of them we have 0 over 0. Because of that, we should have a common factor. The common factor for this one is x minus the limit, which is x minus 2. The common factor on this one is x minus the 4, which is also the limit. So when we have 0 over 0, they will share a common factor of x minus the limit. And because they have the common factor, we can cancel. And we put 4 in for x. Where 4 is 2, so 1 over 2 plus 2, so 1 over 4. So that will be the limit. So that is the limit of function. Next we have question on number 5. Maybe I will do either 6 or 7 as well. This is the limit at infinity. So what we have, here is limit when x goes to infinity. So I will write this very important things. As x goes to infinity, or x goes to negative infinity, a polynomial like this, only the highest power term matters. Only highest power term matters. So in this case, we look at the highest power will be negative 5x squared on the top, the x squared, and then the 3x squared at the bottom. So when x goes to infinity, only those terms matters. So we ignore everything else. And we just have that. And the x squared and the x squared cancel out. So we just have negative 5 over 3, and that is it. Right. So pretty much that. I think we need to do either 6 or 7. I will try 7. Let's do 7 real quick. that was 5. So again, we do the same thing, but this only works if x goes to infinity or negative infinity. Now we go to 7. Right, 7. Once again, x goes to infinity, and the highest power term matters. So we will take the highest power term here, and the highest power term here. One on top, one on the bottom. And then that will be equal to right. 4 and 4 cancel. We have x to the 7 on the top and x squared at the bottom. It will cancel, so we just have x to the 5th, right? X to the 7 over x squared. I'm going to write that the formula. Okay. Here. First we have that. Of course, we'll use this later. And then we just have x to the 7 over x squared. So 7 and 2, so 7 minus 2 is 5th. So in particular, when we have x to the 7 over x squared, is x over 7 minus 2 is x to the 5th. So that's why it is x to the 5th. And when we have x to the 5th, yes, I'll go to 8 in a minute. We have x to the 5th. Then you put infinity in it. And we have that. Infinity raised to the 5th power is still going to be infinity. Right. Before we go to later another question, we did write this down. So, because if we have infinity, could be plus or minus. If we divide by a finite number, it is still going to be plus or minus infinity. If we have plus or minus, a finite number divided by something plus or minus infinity, that is going to be 0. And if we have infinity over infinity, it's going to be indeterminate. So that is what we have here. Number 5. If we put infinity in it, we have infinity over infinity. But that's usually not a problem. What we do is just, once again, when x goes to infinity or negative infinity, only the highest power term matters. So I'm going to leave that at 7 like this. By the way, can anybody confirm the video and the audio? Just make sure that it works. Anyway, I have a question on number 8, so that's what we're going to do next. Just need to check this real quick. Just make sure the trim recording properly. Right, look good. Thank you. Alright, now we go to 8. After 8, I think we need to go back to 1 after that. Right, so 8. First, to find the limit when there's the piecewise function like this, we have to work on the one-sided limit. So first we're looking for the left-hand side. So now we go to 1, but from the left side with the upper script negative of a function. Now when x go to 1 from the left side, meaning it is going to be less than 1, and we're going to use this part of the function because this is where x less than 1. So we're going to have 5x minus 8, because when x less than 1, we're going to have 5x minus 8. And we're going to put 1 in for x. With the minus superscript or not, doesn't matter. So that gives us minus 3. So that is the limit from the left. Oh, yeah, if we have something divided by infinity, it's going to be 0, yes. If we have a finite number divided by infinity, it's going to be 0, yes. And that still is the case. So that limit from the left. Now we do the limit from the right. And when x go to 1 from the right, which is the superscript, the plus superscript, meaning we go from the right, meaning x greater than 1. Right. So limit for the function. If it is greater than 1, we use this part of the function. And we still have that. Negative 5x plus 2 superscript plus. Right. When x greater than 1, we use that part of the function. Now we're going to put 1 in for x, and we're going to have negative 5, 1 plus 2, and that is equal to minus 3. So the limit from the left we have negative 3. The limit from the right is also negative 3. Because those numbers are the same, the limit is equal to negative 3. Yeah. If those numbers are not the same, the limit does not exist. Because they are the same, the limit equal to whatever that is. We get back to number 1 from here. Right. Get back to 1 after this. Right, 1. We do the same thing. First, the function needs to be continuous, and continuous meaning that the function is defined, the limit exists, and that equal those 3 things. But the limit exists. That's the big thing. So in order to do that, we did like we just did earlier. We find the limit when x goes to the left of 3, and then we do the limit from the right of 3. And the limit from the left of 3 meaning x less than 3, So we use this part of the function. And we're going to put 3 in for x. And that's going to be 5. Then we take the limit from the right. Superscript plus. Meaning from this side, which is x bigger than 3. So we use this part of the function. Right. So we put 3 in for x. 4k times 3 is equal to 12k. Right. Because the function need to be continuous, the limit need to exist, meaning those two must be equal. So we have 5 equal to 5, 12k. So we have k equal to 5 or 12. Yeah. Those two functions by itself is continuous. We just need to check the gap, and the gap, the limit exists when those two are equal. So when k equal to 5 or 12. So we have that. And thanks everybody for watching the stream. If you have any question, please put on the chat. The chat is only available on the live stream. On the replay, I will disable it. So don't worry about that. Right. Since we're on limit, and I don't have anybody asking for the next questions yet, I think we need to do number 2 on lap 1. Want to do one of this because this one requires to use the calculator. So here, calculator. Right. First, we're going to fill out the limit, the table, and find this limit. Sorry. Yeah, the question is this: trying to find the limit when x goes to -1. Right. So that is the function. So what we do first, of course, is enter in the function. So we hit y equal 2, and then we enter the function. That is cube root of x plus 1 over x plus 1. So we enter. If you calculator, when you hit alpha and y equal 2 and the bottom menu pop up like this, which means you can use the fraction. So we type cube root of x. Cube root will be under math, option number 4. So we have cube root of x plus 1 over x plus 1. Yeah, so we just like that. And then we hit So we enter the function and then we hit enter. Second, trace, go to calculate. The first option is the value, so we choose 1, hit 1, or just hit enter. Then will show you the graph. And now we just, because from here we say the limit when x equal to 1 is look like something there. Anyway, so we just write the values when x equal to negative 1, 0.1, sorry. We have 0.3228. Let's use 4 decimal places. And then we just keep that on that screen. Just need to change to negative 1.01. Don't need to go through all of that again. Just enter the new value for x, and they give you the y value. So 0.3322. And then negative 1.001. That is 0.3332. So that is nice and all. If you use this calculator, I'm going to switch the calculator real quick. Right. Now we switch to the TI-83. It's still the same thing. Hit y equal 2, and we enter the function. Cube root is still under math. Option number 4. You have cube root of x plus 1 divided by x plus 1. And then second trace, option number 1. It's still the same thing, but the user interface is a little bit different. Right, now we enter those values. We have negative 0.999. Notice the negative sign is here and not there. So 0.3334. And then we just give enter new values negative 0.99, 0.3344, 45, and then negative 0.9, 0.3451. So if you put in negative 1, it will be undefined. Let's try that. What happened? Negative 1. Of course, it's undefined, so it does not give you anything. So in that case, we have to estimate the number that is between this. So you see the pattern that those the numbers. Sorry, no, okay. Don't need calculator anymore. So those number goes to look like 0.3333. So we just need to write like that. Of course, it goes to 1/3, but that is better. Not better, but we just estimate and predict, so that's good enough. Right. Do we have a next question yet? If not, I'm going to go to 4 since we're on this lab 1. And after that, definitely we're going to do number 5. Oh, yes, yeah, that's what I'm going to do next. Number 4, that one. After that, we go to 5 because definitely we have to have 5. All right. So I think this is like a homework problem. So first we find the function where it is discontinuous, and after that we'll tell why it is not continuous. So this is kind of a long problem, so we start like this. So first we say that the function has a gap at -5, so the function go like that, so there's a gap. So we say the function is not continuous at -5, and also it is not continuous at this point, which is 0. So that is where the function is discontinuous, where the function is not continuous. There. Right. After that, now we're going to answer this question. Right. The question is, what is the limit of the function when x go to a? This time a is -5. So we might rewrite the question as limit. Right, try to write very small because we don't have much space here. -5, because that's what a is. Go from the left of the function. And the limit on the left of -5, so we're going to cover the remaining of the function. This is the left of -5. And when x goes closer to that edge, you see the y value just getting bigger and bigger. So that's why it has goes to infinity. Next, we do the limit of the function where x goes to -5 from the plus sign. From the plus sign meaning from the right, and the function go like that on the right. When x gets close to -5, which is the edge of the paper, you see the y values getting bigger and bigger. I mean, smaller and smaller, and essentially it goes to -infinity. Right. So that would limit from the left. Now, since I'm sorry, this one limit from the right, that one limit from the left, and they are different. So the limit when x go to -5, it's going to be does not exist. Because it does not exist, it is not continuous. Right. Also asking what is the values of when f of -3 and -5, and there's no point here, so we say this is undefined. Or does not exist, but a function should be undefined. Right. Now, another point of discontinuity is at 0, so we're going to replace a by 0 here, pretty much. So, first, the limit goes to 0 from the left, so we need to cover everything on the other side. So, it go on the left of 0. Right. So the graph goes like this. When it get close to the edge, if we go along the graph and we get close to the edge of the paper, the y values get close to 0. Same thing when it go to 0 from the right side, the y values get close to 0 as well. So those are the same. So the limit will be equal to that same values, 0. Right. Next, what is the values of the function when x equal to 0? We see that there is no point on when x equal to 0. If the graph is like, let's say it's like this with the dot here, right. If there's a dot here, then we say that is the limit equal to 3. But since there's no dot from when x equal to 0, it is undefined. that is 4. We're going to 5 next. I still left 1. Actually, I have the question left till number 9. That is every rate of change. That is quicker, so I'll go to that later. So not that. So average rate of change. There will be a few formulas we can use. You can either use f of b minus f of a over b minus a, or you can use f of a plus h minus f of a over h. Either way, but I will go with this because simply we do have 2 points here. It is easier to use this formula anyway. So that is the formula for average rate of change. Average is important. Right. So one of them is A, the other one is B. So we just say A is 2, B is 6, right? And put in everything in the formula we have, and of course this is the function f of 6 or as f of 2 Right, so pretty much we just put 6 in for x. We're going to do this by hand first and then we use the calculator. 6 put in for x, so we have x squared plus 2 times 6, and then minus where you put 2 in for it, and 6 minus 4 is 2 is 4. Right, 6 squared is 36. 36 plus 12 is 48, and 2 squared is 4, 4 is 8, so we have that. So that is we do it by hand. Now we use the calculator. Calculator. Wait. Sorry, to put that here. Where's the calculator? Right here. Right. So there's a lot of ways to do this. I usually just store the 6. I hit 6, store into x, and hit enter. Now x is equal to 6, and after that we just enter the function. So x squared plus 2x, and 48, and then we have 2 store into x, and then do the same thing, or we just go up, hit enter, and I'll copy and paste, or we enter it again. It is 8, so 48 minus 8 is 40, divided by 4 is 10. So I would use that formula, average rate of change. Oh, by the way, on the 11 to 13, we just find the derivative, so we don't have to use the definition. We use the power rule. So after this, next we go to 11, 12, and 13. Actually, I think we need to do all three of them. Uh, and I did not leave you much space here, and no, did not make any specification that you have to use the definition. So we don't use that. So we're going to do those three problems. So don't use the definition. Use this, the power rule. So derivative of x to the n power is n x to the n minus 1. Derivative of x, derivative that is 1. Derivative of a constant is 0. So those are the power rule, and we should use this whenever possible, unless on number 5 on lap 1 we do have to use the definition of derivative. I'm going to do that a little bit later, but for now we use the power rule. Right. By the way, let me reply to the chat real quick because that can answer better on the chat. Right. Now we do this. So power rule, this one will be rather simple. So we take derivative of x squared. The power rule say we take the power 2 down. Original power minus 1. Derivative of x is 1. Derivative of 1 is a constant. Derivative will be 0. After that, we have 3 in front of it. A minus 4 times to that, and the minus here. So that is the derivative. And simplify, we have 6x. 6x, 2 minus 1 is 1, and minus 4. Right. So, yeah. Of course, that's just that. So that is power rule, so the derivative. So unless you are asked to find the derivative using the definition, don't do it. Use a power rule, something like this will be a lot better. Right. So power rule. So in order to use the power rule, we need to have the power, something like x raised to some power. So we're going to rewrite this problem to have the powers of x. So first, we have the square root of x. Square root of x will rewrite x to the 1/2. Let me write that out. So we use those formula to rewrite this. Square root of x, you have like 1 and 2 here. So 1 is for the power n for the root. So the power is on top, root at the bottom. Right. I'll just write this for now. Next, we use this formula, move everything up and change the sign of the exponent. Right. Right. So now we have all the power of x, which is good. Then we can take derivative. So derivative of this, first we take the power negative 1/2 down and the original power minus 1. You don't need to write this step. So derivative of this minus 1, x to the minus 1 minus 1, and then x to minus 4, x to the minus 4, and then minus 1 again. All the const, that is the derivative using the power rule. So that is the derivative. Everything above is still a function. Right. For the derivative, we still have 4 here, the minus 8 here multiplied to that, plus 7 multiplied to that. So that's what we have. So we have 4 times negative 1/2, that is negative 2, x to the negative 3/2. Negative 8 times negative 1 is positive 8, x, negative 1 and negative 1, negative 2, and minus 28, x to the negative 5. Yeah. And we're just going to give the answer like this form. That is good enough. So above that, using those formula, so to have the power of x, and then we can use the power rule. When we use the power rule, that is the derivative, so we write derivative equal to that. Right. We go to 13 also. Right. 13. First, we cannot take derivative of individual and combine them. When we combine them, all we can do is the plus or the minus at the bottom. We can do that. A number multiplied to it, we can do that as well. We just cannot have dividing or multiplying. So in that case, we have to rewrite that. But before we do that, let's rewrite the square root as the 1/2 power. Right. Now we can split into x over x to the 1/2, and then 7 x to the 1/2. So what we did was split the top. We can only split the numerator, but we cannot split the top or the bottom. So split the top, we cannot do that with the denominator bottom. Right. Next, this one, similarly to those problems, we can write plus 7 x to the negative 1/2, because we move that from the bottom to the top. That's what we do. We change the sign of the exponent. Right. Now, to combine this, we have this formula. Yeah, I wrote this earlier, and we still use the same thing here. So we have x 1 divided by x to the 1/2, so we have 1 minus 1/2. When we divide them, we subtract the exponents. So we have x to the negative 1/2. Sorry, this is positive 1/2 because 1 minus 1/2 is positive 1/2. This is negative 1/2. Right. Now we have the power of x plus or minus in the middle, so that's perfectly fine here. We'll check the derivative. Will be 1/2 x to the 1/2 minus 1. So the power rule says we take the power down and the original power minus 1. Same thing here. Take the power down, original power minus 1. With plus, then 7 here, right? And we just have 1/2 x. 1/2 minus 1 is minus 1/2. Sorry, the power rule here must be minus 1. Yeah, take the power down, original power minus 1. Forgot that. Next, that's 7/2. And then x to the negative 1/2 minus 1 is minus 3/2. Yeah, and again, we're just going to start it like this. Right after we use the power rule and simplify the powers, that will be enough. Right. So that is finding the derivative and not using the definition. What we used was, of course, the power rule. Right. And also I need to make some announcement on the problem. In class, I say that we have made 16, 17, and 18 on lab 2, and on lab 1, we're going to do number 6 later. So let me type that here. Yeah, I put that on that side, meaning that we have made 16, 17, and 18 on lab 2, and on number 6 on lab 1. We're going to do it, but we're going to do that after the test 1. So meaning to prepare for test 1, we're not going to do that. Right. It's over there. Right. Definitely, we do need to go to number 5 on lab 1. By the way, after 5, I think we cover most of the important details, important topics for the test. If you have any question, please put on the chat so I can see and do it. Right. So this is the definite derivative using the definition. For this one, you need to write very small. We need to take a lot of space. So definition is where we take the limit when h goes to 0, f of x plus h minus f of x over h. So that is the definition of the limit. Need to update the list. Just a second. Right. So, by the way, I did say that those kind of problems definitely will be on the test. You have 2 of those of this problem. Right. So we start with the definition. We'll write that every time. Definition. So first we have f of x plus h. I'm going to do that over here. Pretty much we're going to put x plus h in for x. You should write very small because we need a lot of space here. I still have 6. X plus h square meaning x plus h minus 4x minus 4h. Right. Now multiply out just the factors. X squared plus hx, another hx, and then h squared minus 4x minus 4h. And then multiply it out. We have 6x squared. We have hx and another hx. Make 2 of them. Multiply by 6 will be 12. And then 6h squared minus 4x minus 4h. So that is f of x plus h. I'm going to substitute into this. First, that part will be 6x squared plus 12hx plus 6h squared minus 4x minus 4h minus this f of x is just the original function. Six x squared minus 4x oh sorry, I wrote the limit here correctly, so h go to 0. Yeah, do need to have all of them. H to 0. Sorry. Anyway, remove the bracket. I think we just have enough space here. That is my 6x squared minus a negative, so it'll be plus 4x. Right, now this next two steps are very important. First, if it doesn't have an x, doesn't have an h, it must cancel with something. It does here. That one has an h, that one has an h, this one has no h. That should cancel with something. So we just have those three terms. So those three terms left, all of them have an h in it. So we have 12x, 6h, and 4h, and 4, sorry. We do factor out the h, so 1h here, 1h here, and 1h there. Right, and the h cancel out. So we have limit when h go to 0, 12x, 6h, minus 4. Sorry, can't pronounce space. And then when h go to 0, we just let 0 equal to h equal to 0, so we have 12 plus 6 times 0 minus 4, 12x. So it just be 12x minus 4. Yeah, so 12x plus 6h minus 4, put 0 on for h. We have 12x plus 6 times 0, because h is 0, minus 4, and end up with 12x minus 4. Right, so that was that. Now we do this. We start with the same formula, derivative. When h go to 0, so we have that. So this one kind of simple. We don't need to write on the side like this. I'll just have x plus h in for x, and then minus f of x. F of x is the original function. So we just have that. Right. And we do carve like this. We're trying to cancel anything without an h, and the h at the bottom cancel out. So in order to do this, I will just simplify the fraction. So we multiply top and bottom by the common denominator. Common denominator is x times x plus h. I think I can continue over here. Okay. Or not. Run out of space again. Anyway, so try to squeeze in. 6 x plus h, if multiplied by the common denominator, and then minus 6 over x and the common denominator. Sorry, kind of scram, but the camera does not zoom any bigger. That is close as we can get. Right, x plus h cancel, x cancel, 6x so we multiply it out. And I forgot something. when you multiply this, make sure we still have that at the bottom. Yeah, we do not multiply this out simply because we need to cancel the h. So it's better to have the h by itself like this. It will cancel with something later. Right. First the 6x cancel out, and now we're left with negative 6h, and the h here cancel with this h. Sorry, the h cancel out. Now when h go to 0, we just don't have the h, and we have negative 6 over x times x. So pretty much over x squared, because when h go to 0, just going to put 0 in for h, and that is x times x, which is x squared. Right, so that is b. And now c. We start with the same formula. By the way, after this problem, I think we cover most of the important topics for the test. So maybe we go to 14 in the lab 2, and after that we're done. So if you have any more questions, please put on the chat. Right, so let's do this one in black. Right, first we have that. This is where we put x plus h into x. That's what we have. After that, we subtract. I do this one black ink, so we distinguish with that one, so easier to see. Minus f of x, the original function, and put this in the parentheses. That is that. Now f of x is this. And still over h. Right. Minus that plus 3 square of x. And then you can multiply top and bottom by the conjugate. This technique is similar to the question we did earlier on number 4 on lab 2. So the conjugate, and the conjugate of this, of the sign in the middle, is going to change from plus to minus. And then we multiply it out. Right, negative 3 times that, so we have negative 3 times negative 3, so make it a positive 9. Square root and square root, make it 2. And those two, negative 3, that's a 9. and we have square of x plus h, and then those two minus 9, square of x plus h, and then minus 9, square root of x square of that over h. Right. Square cancel the square root, square cancel the square root, middle term cancel out. That's why we multiply by the conjugate. The middle terms always cancel out. Right, so we have 9x plus h, cancel, minus 9x. Right, so multiply it out, 9x, 9h minus 9x. Cancel the 9, sorry, the 9x. We still have the 9h here. The 9h still there, sorry. Only the x cancel out. Right, 9h. And after that, the h here does cancel with this h. So we just have 9 on the top. At the bottom we have negative 3 x plus h minus 3 square of x. Right. Since we don't do number 6, so I'm just going to use the space here. I mean, we're going to do that later, but so we take h equal to 0 and don't need the limit anymore. What we do now is going to put 0 in for h. So we have 9 over negative 3 square root of x, because there's no more h. H is 0. And give us 9 over negative 6 square root of x. We can leave the answer like this, or we can say it 3 over -2 square root of x. Yeah, cancel 9 and 6, we have 3 over 2. Yeah, we can leave it like that, or we put the negative on the top, still the same. Yeah, so yeah, this is good enough. So when we have the square root, we multiply by the conjugate. The middle terms cancel out, the square cancel the square root, and that's what we have. Right. After this, we go to 14, lab 2, and that's the end of it. Unless you have any question, I can put on the please put on the chat. Right. Equation with tangent line. Given the values of x. So first I will write out the equation with tangent line. Is that equation of any line in general, but what makes this a tangent line is where we have the slope is equal to the derivative of the function at x equal to x1, and that of course the values of the function. So when we look at the problem, the first thing we are given is that x1 is -4, so we say x1 is -4, so that is -4 is going to be here. Next, to get y1, y1 is pretty much the values of the function when x equal to x1, so we write at x equal to x1, y1 is equal to, we're going to put -4 here for x, 16 minus 2, so that is 14. So y1 is going to be 14. Now we find the slope, which is the derivative at the point. So first we find the derivative. Since the function is x squared minus 2, derivative of x squared is 2x, right? So just that. Derivative of -2 is a constant, so that's gone. So pretty much x squared derivative is 2x, and 2 is a constant, so just 2x. So y prime is equal to 2x, or derivative is equal to 2x. Now all we need to do is say that when x equal to -4, so we put -4 into it. -8, right? So that is the slope m, the derivative when x equal to x1. Right, put in everything into the equation. We have y minus y1, that is y1, 14 equal to -8, x minus x1, -4. So y minus 14, -ax, that is +4. Just do that first. Just need to add 14 on both sides. So we have y equal to -ax minus 18. So that is the equation of the tangent line. Right. So I think we cover most of the topics on test 1. So I did not see any question on the chat. So I think this is the last question we did on the review. Thank you very much. Wait, I do have one more question. Number 10 on lab 2, so yeah, not yet. Yeah. So we still have the formula for the rate of change. Again, that one. So let me write that. And now we let one of this be A, and then this B. So B is 8, so we have f of 8, f of 2 over 8 minus 2. Yeah, just B and 8. Right. And the function is square root of 2x, so I'm going to put 8 in it. And then put 2 in it. So 8 and 2 in for x. The bottom is just 6. 2 times 8 is square root of 14 minus square root of 4 over 6. I mean 16, of course. Square of 16 is 4. Square of 4 is 2. I don't know why I have the negative sign. So it's 1/3. Yeah, so 4 minus 2 is 2 over 6, 1/3. So that is, of course, that. Right. Yeah, so pretty much we cover everything. And of course, we omit number 16 and 18 on lab 2. And number 6 on lab 1, we're going to do that after test 1. Probably on the review of in class. Right. Looks like I don't have any more questions on the chat. So this is good. This was the last question we did on the review here. Thank you very much for everybody who on the live stream and asking questions. So it's easier to get things going. And also the video will be online. Probably it take 15 minutes to process the live stream into video for replay, but it will be online. And if you're watching later, thanks for watching. I hope this helped you to prepare for the first test. Thank you. Have a good evening.